have the class here. So you guys know next week we don't have any classes, right? Class is canceled, and I don't think we plan to make up because the week after is going to be your midterm, and I just finished writing my portion of the midterm 2 days ago. Ajahn Atiwong wrote the other half. And while I can't speak for his part, I've seen his part but have not gone into details. You can expect that for the problems that he came up with. So if you know how to do the sample midterm for Ajahn Atiwong's portion, I think you guys should be well prepared. So expect to do quite a bit of reading while taking the exam because there's a lot of text, a lot of reading before you can get to the actual problem solving. And also I noticed that for his midterm, usually he provides you with some code template, so you don't have to sort of come up with the entire code for the problem. Now, on the other hand, for my problems, usually the question is quite short, and they are mostly just derivation from the lectures. So expect to see the problems that I came up with. Expect to see coding problems that you've already seen from the lecture slides with a little twist. So to study from mine, or either the lecture slide or from like your homework, okay? And Ajahn Atiwong and I have been talking about whether or not to give you guys one more sample midterm, just to prepare you for the midterm, okay? So that's the status of the midterm, and I believe there are, hold on. Let me check how many problems so you guys know. ฝนว่าไง หาจ้างติวงเหรอ เอาเหรอ ก็เราเช็คชื่อตอน 9:15 แล้วเช็คอีกทีตอนหลังคาบ ไปนั่งก่อนปะ ไม่ต้องรีบ แน่นอนครับ sure definitely Oh, we made the announcement a couple weeks ago, remember? Check twice. Yes, you were sleeping, Malik. Yes.ไปกินข้าวครับ แล้วคุณไปไหนมา รู้สึกเหมือนกับเห็นหน้ากันอีกแล้ว So you guys are well aware that we have 3 hours to complete the midterm, right? And I just checked, and there are 15, and I repeat, 15 problems on the midterm as of this moment. We might take out some, we might add more, but for now you can expect that there will be 15 problems, okay? All right, and one more news to update you guys. Next week, well, you guys already know that next week we don't have any classes, but most likely, homework 5 assignment will not be due next Thursday at midnight. Most likely, we'll extend the deadline for you so that you don't have to take it, you don't have to submit it by next week. The rationale behind that, Pepia, the rationale behind that is that we want you to have more time preparing for this class's midterm, but also for other exams you might have to take. Okay, so that is again not confirmed, but that's what I talked to Ajahn Atiwong last night about, and most likely it will happen. And that's pretty much the updates that I want to give you guys. we are going to dive into an input and output framework now. And I think homework 5 actually should be one of the simpler homework. Like, it should not take you a lot of times, because the things that you will be asking you to do on homework 5 will be things that are related to input and output, and you can't do much with input-output. It's not a time-consuming portion, okay, or time-consuming programming task. You're just going to be, opening, writing files. That's it. Hey, what's up, Medic? Okay, so now I'm going to start the lecture since it's about 9:10 now. And what do you guys think about when you see input and output framework? What do you think we'll be learning about today? It's right there. Okay, well, I mean, you can paraphrase, right? There's the subtitle right underneath. What do you guys think will be, input and output, right, but input and output to what? From what? Input from, from what? And output to what today? Okay, it can be from web, but that's not what we're going to be studying about today. What else? Files, right? So, since the subtitle clearly states that we are going to be reading and writing stuff, I don't know if you need an S there, but reading and writing stuff to and from the local disk, you can probably guess that we will be talking about files today, okay? Now, before we go on to the next slide, I would like to ask you, why is it that we need files? You guys ever thought about that? Why do we need files? Why do computers need files? I want to make that point clear first before we actually study about the file system. Well, not the file system, but the file API. Why do we need files? I don't. หนักไหมเมื่อคืน Oh. So can anyone give me some answer? Why do we need files? Why do we have files at all? Yes? Okay, that's a really good answer. So we need files to use it, just like how we have computers and we need to use it. No, just kidding. Okay, so we need files because we need to use it, right? But why do we need to use files? What's so special about files? Like, okay, let me give some hints. When we talk about files, what are we talking about? We're talking about storage, right? We're storing something. And I'm sure you guys have taken some, preliminary class that talk about basic computer components, right? What are the components of computer? You have CPU, you have what? Hard drive, and you have memory, right? So do you think that memory is also a type of storage? Yes? So now, here's my question. When you compare, random access memory, like RAM or memory, right? Or flash memory versus like files or hard drives, hard disk. What's the difference? You guys know this.
The data is persistent.
Right. So the key word here, like Putti said, right, is persistency, right? If you have stuff stored in memory, in the RAM, when you turn off your electronics, what happens to that memory? Lost, right? On the other hand, if you had stuff saved to your file, right? If you turn off your computer or your whatever, what happens to those files? Assuming that you turn it off properly, right? What happens to those files? Nothing. So they're still there. So I think the point that I'm trying to make here is that the reason why we need files is because they persist. They don't get lost when you turn off the electronics, when you cut power. Okay? I think that's the key, and this is why you need to have files. Because if you only have memory, then when you turn your electronic off, then all the stuff that you have saved or stored in the memory will be gone. Okay, thank you. Now we can move on to the next slide. Okay, so since we will be talking about files today, I would like to first start by introducing you to this, the types of input and output that you have for the Java I/O framework. Ping. So how many types of Java I/O frameworks do we have? You know that was coming, right? How many? And what are they? It's so obvious how much attention you've been paying, even if it's on the projector. So how many?
2.
And what are they?
Stream, input, output, and random access.
Thank you. So, all right. So what's the difference between stream I/O and random access I/O? Can anyone read the slide and tell me the difference? No, I don't want you to read the slide. I want you to actually paraphrase and tell me your understanding. What's the difference? Why is it called, why is it one is called stream and the other is called random access? Well, the keyword for stream is that it's a type of I/O that is read sequentially. Okay? While for random access, as the name implies, you can randomly or you can choose to read in any position of the input. Now let me demonstrate that visually. If the pen works. It still works. Oh no, but we'll probably want to use blue. Blue and red. Okay. I'm allergic to red color. I'm just kidding. Stream. So when you think of the word stream, right, you think of a stream, like stream of a river or something, right? It comes sequentially. While random access, the key for random access is that the entire input must be known at the time when you actually access that input. Now let me be precise. The kinds of data that is streamed, okay, are for example radio or anything that is live, like TV feed, or like the internet. You guys know that your internet connection is a stream of data, right? Both incoming and outgoing. If you look at your phone, at least on my phone, this is what it looks like. You have H+, I hope you guys can see. That indicates that, okay, you have, edge or 3G, and then you have like 3G, and then you have E for edge. And then you have outgoing and incoming, right? Now my question is, for stream I/O, is it possible to read, how should I say it, ahead of time? Like if data is coming into your phone like this, this data is going in, and this is the time that it comes in, like time T0, T1, T2, T2, T3 indicating, it's some time in the future. Is it possible to read some data in the future? It's not possible, right? And that is precisely the definition of stream I/O. You essentially just get a stream of data coming in or going out, okay? And this is why if you read the slide, it says stream-based I/O supports reading and writing sequentially, right? You can only read what you're getting or what you're writing right now. On the other hand, for random access, think of a file, if you will. If you open a file, right, just like on your Word document or anything like that, you can certainly scroll up or down and read or write to any position of the file. Is that correct? Right? Yeah? So this is why we classify such type of I/O as random access, because if you read the definition, a random access I/O supports reading and writing data at any position of a file, right? And I just wanted to mention this to you so that you know the difference between these two. So is that clear? Sort of? Yes, good. I just want to tell you guys offhand that a type of stream I/O is something like TCP/IP or network programming. That is a type of a stream I/O that will always be treated as sequential I/O. You know, you can't, like we just mentioned, right? If this is your network connection, you can't skip ahead, right? It's always a stream. Now, I just mentioned that random access can be, for example, a file, right? Like you open a file and you can read in any position of the file. Now, I also want to mention that, but you can also treat files as a stream I/O as well, because if you compare random access of a file, by that I mean you open the whole file, you can also open a file but read one line at a time. In other words, you read stream of lines of a file at a time. You can certainly do that. So in this sense, a file is both a stream I/O type and also a random access I/O type. And in today's class, we're going to show you both, how it can be treated as stream I/O as well as random access I/O. However, the majority of the class will be spending on stream I/O as opposed to random access I/O. Okay? So, as I mentioned earlier, we are going to be concentrating on streams today, mostly. And as I had explained earlier, right, a stream, okay, this is the definition, is simply a sequence of bytes, right? Coming back to this example, when you have, your pictures on Facebook coming into your phone, it's coming in streams, it's coming in packets, it's coming in as bytes of data. So how many types of streams do we have? This is I don't really like to classify streams as two kinds of streams like this, but for this class, it's fine. We have two kinds of streams. We have byte streams and character streams. In a couple lectures back, I mentioned that when you have a file, you either have, when you have a file, you either have a character file or binary file. Do you remember that example I gave out? Like maybe the first lecture or something like that? Byte streams, right? Byte and then character streams. Refer to the exact same analogy, or so by byte streams we mean binary streams, okay, coming in as like raw data, like 0, 1, 1, 0. An example of binary data would be your programs. When you run your executable on Windows, an exe file extension is an example of a binary file. How do you know it's a binary file? When you open it with a text editor, you'll see just a bunch of garbage. And that's an example of a binary file. Now, of course, sometimes when you open your text document, you can certainly see a bunch of garbage as well. And that doesn't mean that the file is actually a binary file. It could also mean that your file encoding is incorrect, right? We run into this problem a lot when sometimes you open like really old documents with Thai characters and you'll see them with weird characters, and you have to like select the right font or change the encoding. That's an example of encoding problem for text file. So byte stream is binary format. Character streams is for text file. And I think you guys all know what text files are already, so I'm not going to spend more time on that. So you have this picture in mind, and the first type of stream that we're going to be looking at today is the byte stream. So the first one that we're going to be looking at is this one. And then we're going to be taking a look at character stream, okay? So byte stream is the most primitive stream I/O capability in Java. We have two abstract classes that deal with byte stream, and those are input stream and output stream. The second line is not that important. What's important is the code example that we'll be showing you. You should make sure that you understand that. But the third line is important. Supports reading, writing of a single byte and or an array of bytes. So when you read this line, I want you to think about the APIs that you'll be given or that the framework gives you. It allows you to write either a single byte or an array of bytes. By the way, I have to make sure that you guys know what a byte is. So can someone give me some definition or define what a byte is when we're talking about byte? Well, hold on. You guys know what a byte, who knows what a byte is or have heard of it? Okay, good. Then you know what the next question is going to be, right? All right, we know that 1 byte is equal to 8 bits. Now, what is a bit? That's a good one, Science. Sorry, I don't have any extra credit. So what is a bit then? Okay, binary, right? So a bit is either a 0 and a 1. Binary bit. A digit, okay. So this is, when we're talking about bytes or bits, we're talking about the unit that computer stores to memory. You know, typically computers store everything in byte units, right? If you can open any sort of storage and you can actually like look at the stuff that's stored on that storage, you just see a bunch of 0, 1, 1, 0. Because that's how data is stored. At least that's how I visually view it. So when you guys hear about the iPhone or iPads having the capacity of 16 gigabytes, 32 gigabytes, or 64 gigabytes, giga is simply 10 to the 9, I think. And so that's how many bytes you have, right? Megabit or megabyte would be 10 to the 6. So that's how many bytes you have. And then to get the bits, then you just multiply that by 8.อะไรนะครับ
So I guess we have well, I'm not sure whether you mentioned the policy in class that will pay attention to special class of students when well, as I said, we tend we will give out lots of questions. From now on, questions will be directed to special classes of students in class based on some certain criteria.
Oh.
So I guess it is a good time to start implementing that now.
Yes. So if I remember correctly, Ajahn Tiwong, and correct me if I'm wrong, but
No, it is our agreement, not mine. Okay?
yeah. But I think that to encourage students' attendance and being here on time, I'll tend to ask questions from those students who come in here a bit late. Is that right, Ajahn Tiwong? I'm sorry, I'm just like drawing a blank. I mean, I know that we had that conversation, but if there's anything else that I missed.
The dress code.
Yes, that too. Oh yes, that is actually the main point. No, hold on. First thing first, he and I actually talked about this, okay? It's not a Ajahn Jiwong trying to enforce the rule, but to encourage students to dress properly, and the culprit is not here today actually, so I can't make fun of her, but to encourage that you all adhere to Juฬa standards, dress code standard, right? I'll tend to ask questions more from students who do not dress properly. So if you don't want to get picked on, okay, then dress properly. Right, Milan? Today is still chill. Chill is not serious for Frenchies. Today, I'm just going to ask anyone who's talked a lot, but maybe starting from next week, which we don't have the class, but the week after, which we have a midterm, the week after, then I'll start picking on those people who do not dress properly. Ajahn Jiwong, did I cover everything up for the policy?
I mean, we strongly prefer you dress properly, but to keep the atmosphere, I think we will not kind of like send you to the student affairs and have your points deducted. No, not that. But we'll just, if you would like to dress casually, that means you probably have to compensate by participate more
Right.
in class.
Yes.
That.
We just want to keep it fun, at least for me. Anyway, where was I? Okay, so the API will support reading and writing of both a single byte and an array of bytes. And I'm going to be showing you the API on the next slide. Now, I mentioned that input stream and output stream are abstract classes, so you can't really use them in your application. So the framework actually provides you with file input stream and file output stream that you can actually use to read bytes, okay, to read data off of the file. And we'll be showing you an example in the next couple of slides. But first, let's take a look at the UML diagram as well as the APIs that come with the framework. As I had mentioned earlier, right, we have input stream and output stream as abstract classes, and deriving from those two, you have the file input stream and file output stream. The key from this slide that I want you to just pay attention to, don't have to memorize, of course, are the methods that come with these classes, concrete classes. You can certainly read a single byte by just calling the read, or you can read the entire byte array. So the BA variable, right, is an array, right? A byte, an array of bytes, or byte array. You can certainly, so BA is a byte array, okay? This is, that's what I mean by byte array. It's an array of bytes. You can certainly read starting off of some offset. That's what the off is for. So if you have, offset, by offset we mean this. This is offset. And then the length, this is length, how much you want to read. Okay? You can skip over bytes and you can close the stream. So just pay attention to, just know that you have these methods available to you, but you'll familiarize yourself. If you've never done like file reading or writing before, you get to familiarize yourself when you actually do the homework. Whoops, I think I skipped one. All right, so here's an example. We have a 2D array of that dimension, so the XX are just any numbers, it doesn't matter. Visually on the on memory, that's what a double or a 2D array looks like. So you actually just have an array whose element simply is a pointer to another array. This is how you construct a 2D array, or how the 2D array is laid out in Java. Is that clear? So why is it that the first double here is 3 elements long? It's because the first element of D is 3 elements long, and you can infer from that, right? 2 element, 3 elements. This is not the only way to construct a 2D array, because in other programming languages like C++, a 2D array can be a contiguous block of memory, okay? And actually that makes reading and writing to those cells much more efficient. But since we're talking about Java, this is what you get when you define a 2D array like that, okay? So what we're trying to do here is, given that we have a 2D array of doubles, we want to write that out to file. How do we do that? If you have a 2D array, let's say that dimension is 2 and 3, just like in the, well, it's like, how should I say it? So I think to make sure that we have the image on the screen, I'm going to write this out. So we have 2D array here, and we have for each element, then we have 3, 2, and 3, right? So 3, 2, 3, and 3. So you guys see, right, that this is a 2D array, more or less, I hope. So to write this out to file, I'm just going to write out what we're going to write to the file, okay? So you can certainly write, this is the file. Hold on. So we can certainly write out the length of D. So this is D. We can write out 3. Man, I should do something like this. 4, 5, and maybe just 1. We can write out 3, which is the length of D. And then this is D0. D1, and D2. And then what's the length of D0? 4. What's the length of D1? 5. And what's the length of D2? 1, right? And then from that, you would just write out the length, so the double of each element. So like if you have like A, B, C, D, you would have A, B, C, D, and then, E, F, G, H, I, J, K, right? Do you guys see what we want to write out to the file, the format? In other words, like one way of how you could store a 2D array is to start off by indicating at the beginning of the file how many elements D has, followed by, for each of the D element, what's the array length. That's why we have 4, 5, and 1. Is that clear? If you look at that, and then if you look at that diagram, that's a generalization of how we could write to a file. And I'm giving you a specific example. And then after you're done with the last array dimension of the last element, then you start writing out your data. Okay, is that clear so far, the format of how we plan to write a 2D array to a file? Yeah? So assuming that's what we want to do, then the next thing that we can do is to write the code to actually make this happen. I think it will probably become a bit more clear once we actually take a look at the code, or I hope. Now, since we're dealing with bytes, okay, we actually have to take care of when we to store the bytes correctly to the file. So here you have an array of bytes that is, and a byte is 4 bytes, right? So if we want to store a number, right? For example, an integer of 17, the bit representation of 17, you guys know that it is 1001, right? Just in case you guys did not know, the reason why this is 4 bytes long or 32 bits long is because when you declare an integer in Java, it is 32 bits long. That's standardized. Now, let me just give you a bit of like some tidbits, some information about why when Java first came into scene, a lot of people like it compared to C++. Because when you declare an integer in Java, it is 32 bits by the language standard. However, okay, back when, for C++, when you declare an integer, it used to be that you don't know how many bits an integer is. It depends on the compiler. And you can look at that as both good and bad. Good in that, okay, let's start off with the bad, right? So the bad thing about C++, at least since it's compiler dependent, is that when you look at an integer, you don't know how many bits it is. So when you write data out to files, for example, sometimes when you write out an int, you might get 2 bytes. Sometimes you might get 4 bytes. And there's actually a reason behind that. The reason why they made that compiler dependent, because for C++, right, the language is optimized for, well, it's best suited for high performance application or like electronic system. And sometimes the compiler vendor, they have to make sure that the unit int actually suits the computer architecture. You can imagine that some computer works better when it deals with, for example, 16-bit number because of the hardware constraint. Whereas some computer or some electronics might work better with 8-bit or 32 bits. And this is why for C++, they did not specify that an integer has to be 32 bits so that the compiler vendor can fully take advantage of the hardware architecture. But Java does not care about that. The reason why Java does not care about that is because Java as a language or Java application runs on a JVM, a Java platform. It's actually the JVM, the Java virtual machine that your Java applications run on, that are supposed to take care of dealing with the hardware. So we have a layer. So if to make a comparison, if this is C++ in the C++ world, you write applications, your application, talk directly to the hardware. This is C++. But for Java, your language actually sits on top of Java virtual machine. By Java virtual machine, another way to look at it is as if it's a virtual hardware. It's another hardware that your language runs on top of, and the JVM is the one that is responsible for talking to the hardware. So because of this indirect layer, this is why Java as a language, or the specification of the Java language, can specify that, okay, you know what, for the integer, it's going to be 32 bits. Now, you don't have to memorize this. I'm just giving you some rationale behind language design. Whereas C++, since it has to talk directly to the hardware, and since you don't know what kind of hardware that the C++ language is going to run on, you can't specify things like this. You have to make sure that, you have to let it to the compiler vendor to specify what's best for the hardware that that particular C++ compiler runs on. I hope that's clear. So coming back to the point that you guys actually should understand, enough digression, an integer is 32 bits, and the point here is that we have a number 17, and that's represented as 1001. The reason is because this is two, how should I explain this? But the reason why it's 17 is because this is 2, 4, 8, 16. Since 16 is a 1, so it's 16 plus 1 is 17. I think you guys will learn that in, I don't know. I'm bad at converting bits to integer or decimal. So since we are planning to store this number, integer 17, this is what you have in memory. We want to store it into file storage. We have to map it a byte at a time. And what we're going to do is we're going to be storing the most significant byte at the array element 0, followed by the second most significant byte, which is this one, to the BA1, and so on. BA3, BA3, the third dimension, will be used to store the least significant byte. Okay? All right, in computer programming, this is pretty much universal. You can do bit operations, okay, using these special symbols. So you can do a bitwise complement. A bitwise complement is simply just, if you have 0 and 1, you do a bitwise complement, what would you get? 1, 0, right? I just have 2 bits there. How about sign left shift? Do a 1. Okay, this, yeah, okay. Shift a 1. Should be 1, 1, 1. 1? Or 1, 0. So essentially, okay, maybe I'll just explain it qualitatively. So when you have a sign left shift, you essentially shift all the bits to the left. Sign right shift, you shift all the bits to the right. Unsigned right shift, you shift it to the right while not preserving the sign. Bitwise AND is simply follows this truth table of 0, 0, 0, 0, 1, 1, 0, 1, 1, and then 0, 0, 0, 1. When you have bits, right, like, I don't know, and you AND this, and then you get 0, 0, 1, because it's an AND operation. I think you guys maybe learned this. Bitwise exclusive OR, okay, so this is an AND. Let me just erase everything else. All right, exclusive OR an XOR. You learn this in, what do you call it? The digital electronic. So what's an XOR? 0, 1, 1, 0. How about inclusive OR? 1, 0, 0, 1. Yeah? Thank you. So if this is not clear, just simply try it. Run it on the computer. Like, do this. Declare an integer a is equal to 0, int b is equal to 1, or whatever, and then do like a or b, and then store it in variable c to see what the result is. Neat. So what's inclusive OR? Which table are we talking about when we're talking about inclusive OR? This one. Oh, the last one. I see. I hope by asking you questions, we'll not send you back to the hospital. Just kidding. Okay, how do you convert? So this slide, what we're trying to show you is how you would take a 32-bit integer, int, okay, and how do you store it as byte? I mean, store the integer I, okay, int I is equal to 0 or whatever, 32-bit. How do you store it to a byte array? The algorithm is really simple. So if we start off with I, okay, so the topmost line is the integer we're trying to store. So this is not number 17 anymore. It's actually some other huge number. The reason why we made it like this is so that you can see when we start shifting the bytes how it looks. So the purpose, or what we're trying to do, man, it's really tall, so I have to use the mouse. What we're trying to do, okay, we're trying to store this into BA3 and store this token into BA2, this token or this byte into BA1, and this byte into BA0. That's what we're trying to do. So how do you do that? Well, if you have BA3, if you have a BA, so here, one thing that is missing is that BA is an array of 4 elements and the unit is byte, okay? So how do you do that? Given an integer that is some really large number, 0 hex of, I don't know, 8, 7, F or whatever it is. So one way you can do it, right, is to do a mask, okay, to extract each byte and each byte alone so that you can assign individually to each of the BA element. So if you have this as the number, okay, we're trying to just store this into BA3, right? So one way you can do it is to AND this entire number with 0xFF. Essentially, we're ANDing it with this byte, right? And then when you AND it together, then since it's 0xFF, you know that when you have 0, right, anything that ends with a bunch of 0 will yield a 0. This is why you just have this left, the byte that you want to extract. And then when you have this byte left, you cast it, it's still 32 bits, okay? And this is why to store that byte, you have to cast it to be a byte, and then you store it into BA3, right? Now, how do I get this second byte? Well, one way you can do it is to do the right shift operator. So this is why we're doing a right shift by how many bits? By 8 bits, right? Because we've stored this byte already. The next thing we want to do is to store this byte. This is why we do a right shift, and you can see that now this line becomes this line, right? Because it gets shifted to the right by 8 bits. Are you guys with me so far? So we shift right by 8 bits, we have this again. Now we repeat the exact same process that we did in the first step. By that I mean we AND it with the 0xFF again, and when you AND it with 0xFF, of course you are going to just get this byte left, followed by a bunch of zeros. To extract simply this byte, you simply have to cast it to be a byte. And that's how you store the second token or the second byte into BA2. And you keep repeating this process over and over until you have all the 4 bytes stored to the BA array, the byte array. Yeah? Okay. So now I'm going to run an example, the code that you can use. So this one is, which one is this? So we have writing bytes. Hey, Auntie. For for those of you who are like, whoa, what's up with all these bits and bytes operation just to store a number? You don't have to be worried about this in the real world because first of all, the guys who came up with the Java framework already provided you with another API that you can actually use to store numbers to files. But more importantly, most of the time, you won't be dealing with bytes. Hey, you were just sitting here. How did you? Anyway, sorry for. Seems like V wants to actually participate. And M as well. All right. First thing first. This is the number, the 2D array we're trying to store to the file, okay? And we have a file. Vicky, so what's the file name that we're trying to store? Thank you. Ping. So what's the dimension of data? What do you think the data.length will, if I do a printout of data.length here, what would the number be? Right here, this line. What is an array? If I did a system, 3, thank you. It is 3. So who else? Okay, so back to the main topic. We're trying to write this data variable out to file, okay? And the file name that we're going to be writing out to is called doubledata.dat. So the first thing that we're trying to show you is to, so let me just run this program real quick because then you'll see the output. So this is what we're trying to write out to the file, okay? So this is the output. What you just saw was the output of this snippet of code. And just to make sure that you know how to iterate or traverse an array, an array is data.length, right? So we're going through the data variable one at a time. And we're simply asking each of the array element. Remember, each element of data is what? Is an array. Is what? Da. Can you tell me the data type of each element of data double array? Huh? Yeah. No, hold on. What is the type of each of the data element? Apparently the whole section behind there are not paying attention. Really? It's double? So what's your final answer? Good. So it's an array of double. That's what I was looking for, an array. Good. I'll get you next time. Just kidding. Okay. This is because each element of data is an array. This is why there's a method, ja. This is why each element has the method length or the property length. Okay? So we're traversing through each element of data now, or the second element of data, which is the J component. And this is how you would traverse a 2D array. Okay? The extraneous print lines, they're just there so that you see the ankle bracelet or whatever it's called. I don't remember. I don't even know what it's called in Thai. So when you run this line or this code, this is what you'll get. Okay, just a visual representation of the data, the 2D array. Now here's the part that we want you to pay attention to, because this part is how you would, given a 2D array, for example, how you would write out the content of that array to a file as bytes. By the way, since we are writing out bytes or data, this is why the file is a .dat and not a .txt. Just want to reiterate that. So how do you do it? Now, going back to this example, I erased it. But you remember like what we're trying to write out to the file is like first the length of double D, or no, not double D, the length of the D variable. I meant the double, the 2D array D. Okay, for the next semester, I'm going to change from double to be an integer. Okay, 2D array. 2D array. I'm taking this a bit slow. So we're going to write out 3. See, that line might write in the first line. It's going to write out 3 because it's a 3 element array. By the dimension of each of the 1D array that follows, which I think is simply 3, 1, and 2. So this is what we're going to get as binary. 3, 1, and 2, followed by whatever 3 plus 1 plus 2, 4, 6. So we have 6 long elements here, all of them which are double numbers. I won't mess up now. Okay, so this is what essentially we are writing to the file. Why do you smile like that? Right? So let me just go through the code. Remember, have this picture in mind, right? We have a 3-element array. So my right int nai. So what's the output of this? What's an array? My right int, what number are we going to write out to the file? I'm asking for the number, a specific number. So here, just to show you, I thought you printed out the lecture slide, but what's the number? It's 3, because an array is 3, right? D is an array, a 3-element array. So that's why it's 3. So we're writing out 3, right? And then for each of those elements, we are going to write out the array length of each element. So what's the first one going to be? 3, and then 1. This is 1 because it's a 0.0. And then what? 2. So you guys see, this is what we're going to be writing to the file. Yeah? And then once we have written out the array size, then we're going to be writing out what? The doubles, the data that we want to write. This is why you simply just are traversing each element inside the array now, inside the 2D array, I'm sorry. Is this clear? Because, okay, so if you know this is how you would write out a 2D array to a file, this is how you would write out, then we can now shift our focus to how you would write out each integer or each double. And we wrote a subroutine or a private method to do that. So we have a myWriteInt, so this would write out an integer right? You agree that n array is an integer, array len is also an integer. And also we have another method called myWriteDouble, which would write out a double to the file. So let's take a look at what each method does. Now, before you get all scared of what this is doing, when you come back, no, wait. Okay. So when you, before you actually come here and study the myWriteIn and myWriteDouble, I would like you to go back or to remember that all the code here is really doing is from this slide. We're showing you, for example, how to convert, and you guys know that an integer is 4 bytes long, right? So how do we extract each byte of the integer I? Well, like I said, right, start off with the least significant bit or byte of I, right? We want to store that as byte 3. Here, let me just show the visual representation. Yep, we can erase this now. So, okay, integer I is 4 bytes long. I'm not going to say 32 bits anymore. And what we want to do is we have the variable buff. Buff. What is buff? Oh, I have someone I can ask now. Apparently, he hasn't heard the policy. But buff is a 4 element of byte, right? 1 byte each. So this is a byte. And then we want to, this is the array 3, 2, 1, 0. Right? We want to store, oh, I should have done this, sorry. So this is 0, 1, 2, and 3. So this is least significant. This is integer I. All we want to do is to store the least significant byte to array element 3, second most least significant to array 2, 1, and 0. Okay, that's what we want to do. You have an integer I that is 4 bytes long, and you have an array of bytes that is defined as buff. You want to simply just do this. How do you do it? Well, you can certainly start off from the array index of 3, right? That's why we have an int k is equal to 3, k is greater than 0 or equal to 0, k minus minus. You AND the I by itself, just this I with 0xff, you know that it will extract you this byte. You store that. You have to cast it because when you do an AND, you still have a 4 byte number. Once you cast it to be a byte, it will become a byte, and then you can store it to the byte array element. Then you shift. Then you right shift, because when you right shift, essentially you're getting rid of this, and you pad the I with 0, 0, right? And then the process repeats, because now I is this number, okay? And then, wow, you guys don't meet each other every day or something? Huh? Okay, so you have, so once you shifted I, right, then you have this 0, 0, 0, and then the 3 bytes left, and then you AND that again with 0xff, so of course it will zero out all these other bytes, right? And then once you AND that, cast it to be a byte so that you can assign it to the second element. Is that clear? And then you keep repeating this process forever until you actually have stored all the bytes to each of the buff element. I think,
The first one says int k is equal to 3.
Okay, really good question. Because the number 3 refers to the index of the buff array that we want to traverse. Like we want to store 1 byte at a time, starting from this byte number 3, the last. The reason why is because when you write out to file, this is how you want it to store, like from most significant bit to least significant bit. Because if you started off, if you wrote out to the 0th byte first, it will be reversed. And we want to store it like this. That's why you start off with 3. You guys are probably typically familiar with starting off an array index with 0, but see, since we're storing things the other way around, this is why we start off with 3. Okay, so I think that's clear for my write int. Now, my write double is the exact same thing, with 2 exceptions. I want to first point out that you cannot just write out a double straight up. You actually have to convert it to be a long first. So this is why we have a double to long bits here. In other words, taking in a double a variable d whose type is a double, you have to convert it to be a long first. A long is a 64-bit. This is why the second difference, I can't change this for the next semester because we want to demonstrate how to write a double. So it will have to be a double. Maybe I'll rename the variable to be like double dar or something. Anyway, enough digression. You'll notice that compared to when we wrote out an integer, which is 4 byte long or 32 bits, right? We use only 3. We use 3. Here, since a double by its meaning is 2, double, that's why it's double. That's why you start off with 7. And that's the only difference. Everything else is pretty much the same if you look at the algorithm. So again, just to reiterate, first difference is that for a double, you have to convert it to be a long first using this method. And secondly, you have to traverse the entire 8 bytes or 64 bits. Okay? And we're done with the first example. And actually, this is probably the only example that I'll go into fully because it has the most amount of information that you guys need to know. So here, we're just simply showing you the method that we just used to convert a double to be a long from here. Here, I'll show you again, right here. In my write double method, second line. With me so far? 15 more minutes till daybreak. Okay, now we're going to cover how to read the data back. Assuming that that's how we store it, right? You would just simply read it just like how you wrote the data. So least significant bit or byte will be assigned to BA3, BA2, BA1, BA0. And you start off with an empty integer, so 0, and then you write out the byte 3, right, the most significant byte, and you keep shifting. So once you write here, you shift, and then you put in byte 2, shift, shift. Now, I think the knowledge here, you only need to know for the exam, but in real life, typically we don't deal with bytes. Like I said, most of the time, the API already provides you with how to write to a double, how to write an int. And I will actually show you the APIs to achieve that. But the reason why we want to go over this is so that you are aware that when you're storing things to files, you're dealing with bytes. Okay? That's the unit of all computer storage. So here, really quickly, just to go into further details. If you had a number, okay, that is 4 byte long, and you want to read it back from file and store it into memory, the way you should read this is like this. Start from the left, right, left, right, left, right, left, right. So start off, this is the objective. We want to store byte 3, byte 2, byte 1, and byte 0 into our variable called I. That's what we want to do. So how do you achieve that? It's really simple, right? You start off from I is equal to 0. The BA is the buffer that contains your data that you just read from the file. To extract, right, just like in the previous example, to extract the first byte, you simply do an AND of 0xFF, right, which would yield byte 3, and then you add it with I. That's why I will become that. And then to make sure that byte 3 still gets preserved, you do a shift of 8 bits. And then you repeat the process. So you can see that it comes in chunk, right? From over there down here to down here. It's the same process. You first AND, you do a mask, and then you shift, do a mask, shift, until you have exhausted all the bytes that you want to read from the disk. So without further explanation, using that, we're going to just look at the code real quick. And I think the best way for those of you who might be a bit like puzzled is to simply just run the example in your lecture slide and then see the behavior of what happens. So the next example that we're going to be looking at is the, what is it? Reading bytes. So it's pretty much the same thing as what we had before. So I'm going to skip straight to the code that you should care about, because like here, if you ran this application, you will simply see the content of the file that you just read back. So it confirms that we are reading correctly, okay? So the steps that you probably want to care about is this section, which is simply the array that will allow you to read the data back. And we've already gone over this, okay, so I'm not going to cover this. The most important point, however, is this part, the myReadInt and myReadDouble. And really quickly, given an input stream in, how do you get from that the integer I? You know that an integer is 4 bytes, right? This is why we need to allocate 4 bytes. From the input stream, you read 4 bytes. How come it knows that it needs to read 4 bytes? The reason is because buff is an array, and this method will automatically figure out, oh, you're passing me an array of 4 bytes. I am going to read 4 bytes from the input stream. Now, this input stream is the file. Think of it as the file, okay? And then, again, you go through, so now you can see that buff after this line, after this read line, is now populated with your data that you just read off of the disk. The next step that you have to do is simply just populate your I, right? Because that's what you want to return. Again, you start off from the least significant byte, right? To extract each byte, and you add it to I. And you keep shifting I to the left, keep shifting to the left by 8 bits so that you can keep extracting more data. And that's it, and then you just return I. For double, it's the same thing, with the exception that you have to convert from the long bits to double. So this is the opposite of the previous method that we used. Remember, the first one was like double to long bits. Now this one is long bits to double. Again, just as long as you know like what the AND does and shift does, like why we need to do it, I think that's all you really need to know. Okay, so coming back here. Now, as I had mentioned many times throughout this lecture, that in practice, you actually don't need to manipulate the bytes like this, because the framework actually provides you with the API to do all of these things, right? So if you want to read like an integer, you don't have to read the bytes. You simply read double, or integer, you simply read int or write int. So it's one level up, right? Just to recap. Just to recap, in the previous slide, we've been dealing with bytes. In other words, even though the data that we were dealing with were integers or doubles, but when we wrote it to the file system, we actually had to convert it to be bytes before we can actually write the data to the file, right? Whereas here, instead of dealing with bytes on our own, which leads to a lot of problems, because we certainly can mess up, right, when we deal with bytes, you have methods that will allow you to, write out int, double, char, even boolean or whatever. All these primitive types in Java that are provided in Java. In other words, now instead of dealing with bytes, we are moving one level up. And I hope that you guys agree that if you had a choice between, if I ask you to write out integers to a file as a binary data, I hope that you guys agree that it's much more convenient to use these methods as opposed to dealing with bytes yourself, right? So we are going to be taking a look at these methods now, how you can use them to do the exact same thing that we did before in the previous slides. Just like how we have, I think, what is it? Input stream? No. We had file input stream, right? File input stream, file output stream. Oh yeah, this is how you would just read bytes off of file. You would use this class, okay? Now, we can actually do, if we want to just use these APIs, what we have to do is to use something called data input stream, which takes in an input stream, okay? And this is why, this is an example of a decorator design pattern. And I'll show you, so visually, a decorator design pattern is this. Whenever you have something that inherits from a parent class, but also contains the parent class. And also, not really, but so the data input stream, the class that will allow you to use those convenient APIs like read in, read double, as the constructor, it takes an instance of input stream, okay? And then you can read the data from that instance. Same thing with data output stream. So let's take a look at the example. And I think I'm going to use the slide this time because it highlights the part that you actually should pay attention. First of all, we don't have like my write double, my write int anymore. Do you remember those subroutines, the private methods that we had to implement to extract the bytes and make sure that they put in the right order? We don't need to do that anymore because now we're taking advantage of the Java class called data output stream. So if you remember from the previous slide, if you guys, those of you who printed out the lecture slide, in the previous slide we did not have this. We simply just new file output stream, passing it the file name. But now we are wrapping that base class that class with another class that called data output stream that provides us with these APIs, write in and write double. Okay, this is an example of decorator design pattern. You take something, you decorate it with another class that extends. No, I should not use the word extends. That expands the capability. Because essentially what the data output stream does is doing the same thing that you saw in my write double and my write int. You know, and they instead of calling my write int, they just call it write int. Can you guess underneath write int what it does? Probably the same thing that we saw in my write in and my write double, right? Maybe it's more optimized, but the same idea. You know, it takes an integer and it writes out to the file for us. So we don't have to worry about, you know, shifting the bytes or doing all those mask, you know, 0xFF that we had to do. So what's the point? What is the point that I want you to take away from this? If you had a file that you want to read, a binary file, I should be precise. If you had a binary file that you want to read from, and they're just like a bunch of integers or doubles, then you can use something called data output stream to wrap the file output stream. And then you just write straight up to it. So you can see that our code is now a lot more concise, right? Personally, I find that this is more readable, right? It's very simple, right? We open a file, we write a number, and then we looping and we write an array of numbers, or we write a bunch of numbers, and then we write a bunch of doubles. It's very clear. So this is the benefit of knowing how to use the right class. Imagine that you did not know that data output stream existed. Then each and every one of you would have to write your own version of my write in, or your own version of write in and write double. But because in this class, we want you to focus on reusing existing APIs that are there to help make your life easier. This is why we encourage or we teach you that, hey, you know, there are actually these classes that make it more convenient, less pain-free way to do what you want to do. Okay, so this is an example class that you would want to remember. And so in the previous slide, we took a look at how to write, right? Here's an example of how you would read. So just like how you have write int, you would also have read int. The opposite of everything of the classes in the previous slide, which were all output, are simply just input. Okay, so these are the things that we want you to take away from for this slide. So we talked about writing primitive data types like integer, doubles, char, boolean, and what have you. Now we want to talk about writing out objects. What's an example of objects? Like, what are we talking about when we're talking about objects here? I mean, didn't someone say that everything in Java is an object, like a class? So what do we mean by objects? Like, I thought we were writing objects out, like, you know, integers. Those are objects too, no? So what's sign? So what do we mean by object streams? You'll be quiet now. Anything, actually. Anything, you know, like a class that you implemented on your own. For example, let's take a look at, for example, if you had a class car with properties of I don't know, with some properties like the number of wheels, steering wheel, accelerator, engine. Because at the end of the day, every single class is composed of primitive data types. And those are like the integers and the doubles. So what are the basic components? Yeah, you can turn around. So what's an object, Nid? What's an object? Then you would want to listen then. No? Fiem is next door, you know. He talks to me almost every day. Okay, so when we talk about a class, an object, at the end of the day, any class is composed of primitive data types, right? It has to be. So my point is that when we talk about object streams here, we're talking about any class that actually implements serializable. I sort of lied when I said that any class you can serialize because it's not true. There are some classes that contain, for example, might contain other classes. Those might not be serializable, like might not be, you cannot write them out to disk. What is the one thing that you cannot write out to disk? This is actually a tricky question. No, I'll just give you the answer. At least in C++, for example, like pointers. Do you guys remember or know what a pointer is? What's a pointer? Okay, actually I should reword my question. So we talked about, you know, writing out stuff, right? Like int, double, character, boolean, right? Those can be written out to disk, and then once you restore them, you can reuse them again. But what about a pointer? Can you actually write out the value of a pointer to the disk? And perhaps before I ask that question, do you guys know what a pointer is? So a pointer, there's no such thing as a pointer in Java, or at least not officially. But a pointer is simply a variable that holds the address of something. Just like how you store an integer to an int variable, right? A pointer is a special type of variable that that contains the address of other objects or of memory address. Now, might be a bit deep, but I'm gonna try it anyway. Since we are storing the memory address in a pointer, right? And since you know that once you turn off your program or you turn off your computer, the stuff inside the memory is gone, right? That means that if you wrote the address location onto file and you restore it back and you try to reuse that memory address, my question is, would that address still be valid? In other words, would that address still be available, or would it still point to the same object that you were pointing to? No. So the point that I'm trying to make is that there are certain things that you cannot serialize to disk. Okay? In the ideal world, you can serialize, so the term of like writing out objects to disk is called serializing. You're writing out everything to disk. And I'm trying to tell you that there are certain things that are not serializable to disk. For example, so I was talking about pointer, right? Now, here's what I am actually mean. Suppose that you had a class car, but within the class car, you also have another class called wheel. I don't know if that's a class wheel. Car is composed of simply just a bunch of integers, okay, as properties. You know based on our example so far that we can certainly write out integers to disk, right? But see, here's an exception. When usually a class is not serializable if, or cannot be written out to disk if it contains other classes within its own class. Okay? Unless that class actually declares that it is serializable. So the point that I'm trying to make is that any class that you see that does implement serializable, these are the classes that whose object can actually be written to the disk or to any sort of input-output, can be serialized. Is that clear? And I'm just trying to tell you that there will be, for those classes who do not implement serializable, it simply means that probably within the class, it contains some other classes or something that prevents it from being serialized, being serializable. Is that clear? The whole reason why I brought this up is because of that serializable keyword. So serializing is the term that we use to say, to mean, to write object and all the objects that are referenced by the object to a stream. And deserializing is the other way around, to restore from disk or from some input to reconstruct the object. So just to make sure that you guys see that visually. Now we're not talking about we're not talking about files anymore, okay? We're talking about a class. Let's call it a car. Yeah, a car. When you this output. So this is some sort of I/O. Serialize would map or would translate, convert the object to some input-output device, and to deserialize is to do the opposite. Okay? Man, our class is so eventful. What's wrong, Em? Oh, too cold? Why? How come he's not adjusting that conditioner? You want to be on camera? All right. I think I went past. I went past the break time.
Let me have another 5 minutes just to give you some concrete motivation of why would you like to know how to save an object. Okay. So actually, the keyword was homework number 5.
Oh, putty. So that's actually a lot more than just writing file. Oh man.
Last night, but something stopped me. But anyway, good news is that we will not give our homework 5 before becoming exam.
Oh.
I would like to think about this. Suppose it was supposed to be that in your scribble shop, right? Something were missing from the file menu, right? You have new, you have close the window, you have quit the program, right? Normally, what would you expect to see in those menus? Save and load, right? Think about how would you be able to make your program to be able to save the picture in the windows in your own file.
Screenshot.
Right? And then you should be able to load or open that saved word back again. It's not complicated at all. Think about that. In each scribble applet, what are the underlying data that you need to paint the window, to paint your screen, your canvas? You probably have some collections of lines, right, or points, right? The thing is that in Java framework, you do not have to kind of implement the logics and save each attributes one at a time. It's much simpler than that. You could try that, right? For example, the whole applet is one object. It can be set in just one line. You can use object string to serialize the whole states of the object, the instance of that object, into a file without having to care what are the binary formats that Java does it for you, right? We can set that. And how do you load it back? You use the same object, deserialize the link with just one line, right? And get the object back. The tricky part is that it works with all objects whose class can be serializable. You know what I mean? It means that some class it works this way, but for some classes it does not. Yeah, but luckily many of the classes are serializable. But you could try in your Scribble shop. You could try whether you can serialize the whole internal frame, or can you serialize the whole applet, or can you just serialize just the collections that store the value. I leave that for you to try it out, but that's probably give you some rough idea of how powerful object screens are. Okay.
Thank you ครับอาจารย์ติวงศ์ And with that 10:45 now take 10-minute break okay as long as the elements are serializable okay methods to serialize and deserialize are declared in object input and object output interfaces. So let's take a look. So just like how we have, what was it? Like file input stream, right? We also have, so just like how we had file input stream, right? We also have object input stream and object output stream. So that would be the concrete class that you want to use to serialize your objects. Which object? That was actually a rhetorical question. There's no answer. I just thought of asking on the whim. All right, here's an example of writing an object. So you have a 2D array called data, and you want to serialize, you want to write this out to file. So we're taking this even one step further. Let's see. If you remember, the very first example, right? This is really interesting. Whoa. Flying eraser. So we have bytes. At first we were dealing with bytes, right? This is not a comedy class. What's so funny? Huh, Ping? So we have bytes. The very first example that we took a look at was bytes, right? We had to manipulate the bytes. Next level up, we dealt with int and doubles. In other words, primitive Java data types. Now, we're actually going one step further. We're actually writing out. We don't have to concern ourselves with each element anymore. We're actually writing out the entire 2D array all at once, provided with the mechanism provided by Java itself. So in other words, now we are going one level up, and the code is now much more simplified if you take a look. It's still the same double data, right? That's it. Instead of D, it's going to just be called data. That's a lot better. So now we have a 2D array called data, and we want to write that out to a file, okay? And the file name is what, Sai? No, wait, what? What's the file name? What? Okay, double data. 3. So we want to write out the 2D array out to a file name called doubledata3.dat, right? And whereas in the previous slide, we had to go through each element and explicitly write out each element. Now, with a decorator or with another class called object output stream, okay, wrapping the file output stream, we can simply use that class along with the write object method to write out the entire variable data to disk. So you see how as we go up in the abstraction, the code get much shorter. And this is the, what do you call it? This is the benefit of using higher abstraction language like Java versus having to use assembly to write your application. Imagine you have to write or do your homework, I don't know, for using some other lower level languages like assembly or C. You can probably imagine that it'll take a lot more code just to accomplish the same task, right? And I hope you see from this example, whereas in the previous example, we had a lot of code, probably maybe 50, 60 lines of code. Now we only have 2 lines to write out something to a file, right? In this sense, then we are serializing our object, which is a 2D array, to a file. So do you guys see the benefit? Now just 2 lines? Okay. Now, we just talked about writing objects. Now, how about reading objects? Same thing. As opposed to, instead of using object inputs or object output stream, you use the opposite, which is the object input stream. Okay? And to read the object back, you simply just do a read object, but you have to cast the type to be the type that you're expecting. And the type that we're expecting is the double array data type. And we can do away with all the details that we had to do in the previous slide, because as an application programmer, do you care the format or what you write to what you write to disk? Remember the format, this format? You probably don't, right? I mean, your objective is to simply write out to disk the 2D array. How it's done, you could care less. And that's what the API, if you don't care about that detail, then you can use this class, the object input stream and object output stream, to achieve what you want to do. So we just talked about, I think this is an important point. We just talked about the benefit of having a higher abstraction API, right? Starting from bytes to int doubles the primitive type, and now you're dealing with objects. How about the cons, the downside of having higher abstraction languages or APIs? What do you lose in terms of trade-off? Specification. In short, at least in my opinion, higher abstraction methods or levels of programming languages essentially you lose the ability to specify exactly how you want things done, right? For example, coming back to this example, right? Now you lose the ability to define your file format if you use this method, right? So you're making that trade-off. You're trading off, less line of code versus the ability to specify how you want the file to look like. in software engineering, just like all things in life, I think whatever that you do, there are always trade-offs, right? And I think you'll see that theme more recurring very often as you program. Sometimes you find that something is really good, but you actually have to make a trade-off against something. So that's that for the serialization of objects. Now I lose the diagram, but now we're going to be talking about character stream. So from the top level view, we've been dealing with bytes, and by bytes I mean binary data. As I had alluded to you earlier, we have two types of data, I.O., if you will. We have binary and we have characters, right, or text. So now we're going to be talking about character streams. So in Java, strings are represented in Unicode. How that is pertinent to you, simply it's just with Unicode encoding, you can pretty much use any languages you want. Prior to Unicode, it was very easy to create something, universal encoding scheme that everyone can agree upon. But these days, Unicode is pretty much a standard. Character-based I/O streams perform conversions between the Unicode and other character encodings when reading and writing strings. Abstract classes that you would want to pay attention to are the reader and writer classes. And just like how you could read a byte, at a time, with here, since we're dealing with characters, what are we reading one at a time? Da. So with character stream, what do you think we're reading? What's the unit? Yeah, character. We're reading a character at a time. The unit is a character now. Or an array of what?
Array of characters.
Good. Wow, so you can multitask, right? You can like listen and also talk at the same time. Would you like to come up here and be the lecturer? So the net. So the methods. So the methods that we have provided, I have something for you later, you'll see. The methods are very similar to what we saw earlier when we dealt with binary data or bytes, right? You have read starting at certain offset and close as well. Okay, so now we see the reader class hierarchy, okay? And the classes that we are going to be looking at are these three. Input stream, first we're going to be taking a look at the input stream reader, and then I think we're going to move to the file reader, and then we're going to be taking a look at a buffered reader class. And for each one, I'm going to tell you why you would need them. And actually for this one, I have a real-world example or story to share with you as well. And just have to wait until we get to that slide so I can talk about it. The writer class is similar just to the reader class, nothing exciting here. All right, so input stream reader and output stream writer serve as bridges between character-based I/O and byte-based I/O. We're going to be showing you an example of what we mean by that. Input stream reader reads bytes from a byte input stream, okay, just like for example, like the input stream class, and converts them to characters according to a specified encoding. So here we're reading data off of the whatever file, and then we're converting it to be characters. Don't worry about this. This is just like formal definitions of what it does. I think best to understand by looking at the real code, which we'll show in a couple of slides. Output Stream Writer, on the other hand, converts characters that you have in your program into bytes according to a specified encoding and writes them to a byte output stream. So input stream reader, the constructor takes in an input stream, essentially the source of where you want to read from, and optionally the overloaded constructor also can take in the encoding that you wish to have for your file or your text. Similarly, output stream writer and also have two constructors that pretty much do the opposite, doing the write as opposed to doing the read. So here's the first example that I want to show you. So here we want to essentially read from a text file and print out the content of the text file. And this is test input stream reader. So first I'm going to run the application. Wait, did I mess up? Hold on. I had this prepared for a net. Hold on. The file is called document1.txt. Yeah, this is the one. This is the one. Did you see that, M? But the encoding is incorrect. Hold on, let me take off the encoding. I don't know if... No, it's already down there. So, can you guess what the content of this file is, Net? So what's the printout? Told you I had something prepared. All right, coming back to, I already printed. All right, so in this example, right? We're in computer science course. All right, so we have the file input stream to read the file, right? And then to read it as a text file, you would simply use the class called input stream reader. Right? So the point here that I want to make is that you would use the input stream reader to read a text file. And as you saw in the previous slide, you can use the method called read to read the text and then to print out the character. And then the reason why it's a while loop and then not equal to -1 is because the read method will return a -1 when it reaches the end of file, or EOF, okay? And then in the end, you have to call a in.close to close it. And this is the content of the file, as some of you had already seen. Output stream writer. So let's take a look at another example. So we just saw how to read from a file, right? Now let's take a look at how to write to a file. Output stream writer. Very simple as well. Again, you start off with the file output stream, right? And then you use the decorator design pattern again. This time we use the output stream writer. And to write out each character, you would simply just do a write and then passing to it the character you would like to write to the screen. I mean, not to the screen, to the file. I don't think there's anything else we have to cover there. Now, I would like to compare this one and the other one called file writer. So test file writer. So comparing this one and this one, you can see that, hold on, let me close out. 1, 2, 3. So you can compare this one, this example, which we use 2 classes to write something to a file, versus this one, where you simply just instantiate a single class called file writer, and then passing to it the file name and whether or not you want to append to the existing file, if you want to append to the file if it existed. So you can use file writer as a shorthand version if you want to write to a file without caring about having to use this. So I hope you guys see that by using the file writer class, you essentially save quite a number of characters as opposed to having to use 2 classes. They achieve the same thing. As for the second parameter, which I had already mentioned, you would pass the flag true if you want to append to the file when you write to it, and you would want to pass in false if you want to simply just wipe out the existing content and start writing out everything again. So I think that's clear. I don't think I have to write or run this application. We'll just keep going. Buffered reader. Oh, we'll finish on time, definitely. Buffered reader. So you remember that I told you that I have a little story to tell you about buffered reader. Before we get to the story, I'm just going to quickly go over what is a buffered reader and why do we need it. Buffered reader provides read line, okay, as opposed to read. So why is it called buffered? What's the point? Well, characters are buffered so as to provide for the efficient, and that's the keyword. When you use buffered, the keyword is efficient, okay? Provide for the efficient writing of single characters, arrays, and strings. So why do we say that it's efficient? Well, the answer is in the next line. In general, okay, a writer class sends its output immediately to the underlying character or byte stream. Unless prompt output is required, it's advisable to wrap a buffered writer around any writer class that you use whose write operations may be costly, such as file writer and output stream writer. So how do you use it? The buffered reader writer, you would simply just wrap it around the writer that you're currently using. And we'll have a specific example to show you in the next slide before I get to the little story that I want to tell you. So here's an example. Without having to go into the IDE, we can simply show you what the buffered reader, how to use the buffered reader. How do you use the buffered reader? I can see that you have fully recovered from your sickness, Namit. Okay, so you would use the buffered reader. So just like how compared to the previous example, we simply just had the file read. Oh man, jabu sai kadong. Buffered reader. So we did not have buffered reader in the previous slide. We just had file. Half an hour more. In the previous slide, we simply just had file reader, right? But now, because we want the write or the read to be more efficient, now we're wrapping it with the buffered reader. And like I said, in the previous slide, the buffered reader provides the API to read a line at a time, which is why we have a read line method. So with this example, we are showing you how to efficiently read from a file. Now, why is that? Why does this matter? Why does this matter? Let me tell you a story 4 years ago, 5 maybe. This was the system that I designed when I was working in the US, and it's very simple, and it's going to illustrate why is it that you would all want to remember buffered reader whenever you want to have, whenever you're dealing with applications that are time sensitive. By time sensitive, I mean it needs to be fast. Here, I'm going to draw the application that we worked on. Hold on, I don't want to use red. That one is going to go to the trash can. Okay, back then we had a mini submarine. We call it AUV, and what this little vehicle does is that it has a cable that transmits data that it gathers from the sonar. So this is the sonar, okay? The sonar simply just emits sound, right? And then whatever sound that comes back to the receiver, that is the signal that is being transmitted over the cable. And this is our boat. And this me right here. And that's the computer that I was looking at. And here's my boss sitting right behind me with a whip. Okay, and essentially this data is wired to our computer. And on the screen, you would see the seabed in real time. The seabed, the actual image of the seabed, okay, in real time. Of course, we did not want to just look at the seabed, right? One of the things that what was one of the things that we also wanted to do, Vi? Now, I'd be surprised if you can actually answer this question.
You didn't tell us yet.
That's why you should listen. So, on the screen, we were simply seeing the seabed scrolling down, right? Because that's what the vehicle was recording for us. Of course, one of the things that we wanted to do as well was to record the data that we were collecting. So, one of the things that we had attached to our computer was a high-performance external hard disk. Okay, you guys can see fine. So we also had, in the application that we developed, had a thread. You guys know what a thread is now. That had a thread that was responsible for simply writing data or recording data to disk. Okay, so while I'm not trying to get off topic, but one way that you can architecture your program whenever you have a stream of data coming in is to have different threads responsible for doing different things. For example, you can have a thread that is doing a read, another thread that is doing a write or record, and another to maybe output to the screen. And this thread was writing directly to my external hard drive. You guys with me so far? So a thread is an independent thread of execution, right? So these three things were doing things independently. That's why it's a thread. There were doing all these operations simultaneously. One thread reading the data off of the vehicle, another thread recording data, another thread outputting to the screen. So that's how we architected the application. The problem that we had, that we ran into, okay, we found that over a long period of time, the recording device was not, or the hard disk was not keeping up with the data that was coming in. In other words, just like flood, right? When you have more water coming in than you can actually relieve it, then you have like a big flood, right, in the input. So we were like, what is the problem? Because, I mean, I was simply writing, like if you use the write method, we were simply writing arrays of data to the disk. I was like, what was wrong? We were like doing a bunch of write the header. So our data that we record, the format was very simple. You have the header information, and then you have the signal that you want to record. Okay, this is we call this acoustic data. It's basically just a complex number. Okay, a pair of complex number, real and imaginary. And then you have the data that contains like timestamp, the vehicle heading, latitude, longitude, and all that stuff. So how we wrote the application in our application, we had two write methods. Okay, we had two write methods. One was writing the header, the other was writing the acoustic data. The problem was that it was too slow. It was not keeping up with the data that was coming in, right? And then it backed up the whole system. It took me like one afternoon to finally find out that I forgot to turn on a flag to do a buffered write. Here's what I mean. Each time I called the write, it would write directly to the hard drive, okay? Every time I called the write. What we wanted to have happen instead was each time I call write, I wanted the operating system to buffer the data until it had enough data to do an efficient, and then that's the keyword, an efficient write to the disk. You see, you guys can try this at home as well. Try writing two different programs. One program writing one character at a time and put it in a tight loop. And then time it. Time to see how much time that would take. Like let's say you wanted to write, 50,000 characters, one character at a time, versus writing the entire 50,000 characters all at once. You'll see that whenever you write something contiguous, something really big, all at once to the disk, it will be much more efficient. It will be a lot faster compared to if you were to write one character at a time. And that's what we discovered. So this is how buffered writer-reader comes in. Because with buffered reader, it doesn't matter how many times you actually do the read or the write. It will wait until certain amount of characters have been requested, then it will initiate the read or the write. And that's why we say that it's efficient. So in the future, if you ever have to write an application that has to be performance intensive, it has to be fast, and it has to read or write to disk, or even like networks like TCP/IP, remember this. Remember that each read or write to the actual device actually has an overhead. It has some cost associated with it. Ideally, you would want to read as much as possible from the device, okay? So that's the lesson that I want to impart to you guys. And believe me, it was not fun. Each day we had to rent out the boat, cost us about $20,000, 20,000 US dollars. So that's what, 600,000 baht per day. And when you have like your boss sitting behind you and he doesn't know how to program and he's wondering like, why the heck the program is not working? And to top it all off, you're sitting on a boat. If you want extreme programming, try programming on a boat. Seasick it's like beyond. I don't get seasick, by the way. Like by that I mean, if I get on a boat, it doesn't really matter like how rocky it is. I don't get seasick, but I definitely got seasick when I had to program while on this big boat. I mean, it was a big boat, so it was not that rocky, but still I got seasick and it was like really bad experience. So I hope you guys actually listen to me today, because like maybe in the future you have to do something like this, you wouldn't have to get seasick. Yeah. Huh? Yeah, you should avoid programming on a boat, definitely. I don't know about programming on an airplane. I mean, like those fast airplanes, I'm not talking about commercial airplane. I think you probably won't get seasick or airsick. Anyway, so that's my little story. And now we are on to the last example, the last topic for today, and that is random access file. So we've been talking about stream, right? We've been talking about data sources that only allow us to read sequentially, or at least we intend to read sequentially. Now we're going to be talking about data sources that will allow us to, or input-output sources that allow us to randomly read or write. Let's take a look at what it looks like. So for this lecture, we're simply going to be talking about a file. Just like how you have a file reader, a file writer class, now I would like to introduce you to another class called random access file. And to use it, you simply just pass in the file name as well as the mode. For those of you who are familiar with Unix systems, you know that you're probably familiar with R or RW, which stands for read or read and write. W stands for write, R stands for read. Okay, so that's simply the mode of how you would want to access that file. The random access file class implements both data input and data output interfaces. Provides methods, additional methods compared to what we saw previously, in that you can also move the read and write position by using the seek and skip bytes methods. So, an example is, suppose we had a text file that looks like this, okay? And we want to now see how we can randomly access the file. So this is the last example. Just like how we could use a file reader, a file writer, if you want the ability to basically skip to any position of the file, then you would use the class called random access file. And what is the mode that we are doing to this file for this example? Thank you. So you remember the content of the text file previously, right? The first line is bar and swallow. Bar and swallow. Bar and swallow. Man. I don't know. You tell me. So once you've initiated or instantiated the random access file, if you did a read line, right, it's simply going to return you the first line. First line is defined as all the characters until the first new line. This is why when you execute the second line, out.println .read line, on the output screen you'll see bar and swallow, because that's the first line. And if you want to skip bytes, like you want to skip ahead. Now you see, this is the definition of randomly accessed file, right? You can skip bytes. You can traverse to any point, any position within the data source, which is your file. So if we skip 10 bytes, you know, since we read the line, right, the file pointer is here. This is why when we skip 10 bytes, if you count the characters, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You skip 10, and you do a print line of a char and read a byte. By the way, a character is a byte. That's why you will see a W. Now, seek 0 simply resets the file pointer back to the original location. So 0 is a number, the byte number that you want to get to in your file. Okay, so if you put in 1, you probably be here. Okay, that is not a constant. By that I mean you don't need to put in 0. So if you reset your file pointer from here to 0, and you do a write bytes, and you pass it quadruple A, is it quadruple? Okay, yeah. Then what you're going to see in your text file is this. Essentially, you're replacing barn with quadruple A. Yeah? So on this slide, we're simply trying to demonstrate to you that you can do a seek, okay? And that you can do a skip bytes. And that's pretty much it. So that's pretty much all I have for today's lecture. And I would like to ask Ajahn Atiwong if, so homework 5, you don't have to introduce anything today, right? We'll just save for.
So you have, so next week, because of the change in the schedule of the midterm exam, we do not have the lecture. So this is probably the last official meeting, right? The last official meeting before you go to the midterm exam. Okay. There are 2 weeks roughly from now, and if you have looked at your schedule, the scheduled midterm exam for this course is March the 1st in the afternoon. Okay, so prepare well, right? We might have some office hours arranged before the midterm exam. We will let you know via the Facebook group and post below. Okay, and we will definitely post some practice problems that I believe it might be useful for you to prepare for the midterm exam, because we do not want you to just simply go into the exam room and get surprised by the questions in the exam, right? Another thing I would like to remind you is that please at least take a look at the past midterm exams that we have posted since last week, right? The style, the length, well, at least there are some similarities. Of course, not in terms of the details of the problems, but at least you get some sense of what to expect. And yeah, that's pretty much it. Probably we might need to check some attendance.
Oh, sorry, Ajahn. Okay, we're going to go through this quickly. It's check attendance time. What's the date today?
อยากอยู่นี่15ครับมีก่อนได้ค่ะ15
ชยุทธพีรพงศ์พาทรวิพลกุลประภาจอมพจน์ชวินชัยชนะนัชชาฐานีนัชชาตะเมียนสถิตนัททนายนัททนายธนัทประกรณ์ธนินทร์พงศ์ณพล I feel like a high school teacher นัทพงศ์นัทพงศ์ do you have something to say today นิชดานิรันดร์ปวีปรินวลิดาจา next time I'm going to ask you จา next time I'm going to ask you can you come up here and help me take attendance now I think that if I take you away from the group, it will be a lot less, loud. ไม่ต้องหรอ You don't have to เอา no โดนเช็คด้วยดิ
พอพงมาเลยอยู่โน่นพอพงพอพงพลทกรทัศสินตีให้หมดเลยไม่ต้องพูด
ไม่ต้องพูดครับ นี่คือการใช้ประโยชน์ ความสามารถส่วนตัวให้เป็นประโยชน์
พีรเสริญพุทธิโอพัทราพรคือใครวะแวร์ดิจีฮะ
X X
ไม่ชุบวอน
no X ก่อนโอ้
ไม่ชุบพรแค่วันเดียวเดี๋ยวเอาไปมันชุบพรเมทัศน์
เฮ้ย มัน X นี่ทำเขาไม่มา
ใครไม่มาคะ
มันจุดพรไม่ใช่เหร
มั
อ
นชุบพรมาค่ะ
อ้าวไหนแวร์
ไม่มาค่ะ
โอ้ my god
วรเมธวรพร
what
วรพรอาจารย์ลองฟังเสียงเขาดูจะอารมณ์วรพรจะพูดสิวริศบัววสิน
She realized that we are different areas.
too late that was the point all along
วิริยาเรืองสิริธรชูสุภัทรพรโปชื่อนามสกุลไม่เป็นมงคลเลยโปแพ็คฮารินอธิชาอภินัท
oh my god
เดี๋ยวใจเย็นๆนะขอโทษนะอภินัทมาอภิวุฒิเล่นกล้ามอยู่ใครที่ไม่แย่ว้าวไปแล้วนะเอาเธอเป็นเด็ดแล้วกล้ามเป็นสี่เหลี่ยมค่ะมึงลำดาวอวิกาอา นันยอด กินกุ้งอยู่ โอเคปะจิรายุ ไม่มาพศพลพศพลพศพลไม่มา นิตยา
พี่นิจยา
อดิสากงจีสติงเมื่อกี้ตอบมาเสียงดังต่อไปต้องเป็นชาโชออนทรี
โอ้โห
นี่ชื่ออะไรเนี่ย
Give it a try. Try it. No, try it. Try. And read.
กาลาดิน
Oh no. No, 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 no. Can you tell her how to pronounce your name correctly? We're gonna be.
เจลาติน
Oh. Oh my God. Nah. Oh my God.
ชื่ออะไรนะ
Jelly. เอา
ชาร์ลอตเต้ชาร์ลอต
เขาสาบอกแล้วโอ้เขา Did you hear?
อายุชาร์ลอตโอเค
Go. No, the whole thing.
Gary Benedict
Oh, yeah. Thank you. Okay, class over. See you guys 2 weeks from now.